Good day to all. Today we from Group H will present the finite element analysis project done on a strut bar. This group only has two members, which is myself, Emil Zikran bin Badardin, and Nur Shami Razik bin Hamidan. Let's first look at what is finite element analysis. Finite element analysis, or in short FEA, is a product of the digital age which uses matrix methods and finite difference methods of analysis. FEA is a computer-based analysis tool for simulating and analyzing engineering products and systems. Now let's look at what is a strut bar. A strut bar is a stiff metal bar which connects either the front or the rear strut towers of a car. This allows it to add rigidity to the car and can reduce car body rolls. For the first load case, we considered a vehicle taking a corner while experiencing 1G force. A few assumptions must be made, such as 100% of the car's weight is transferred to the front wheels only. The weight distribution is 50-50, there is a frictional force acting along the tire towards the center of the vehicle, and finally the frictional force creates a friction moment, which then creates a reaction force in strut bar. Running the simulation, we can analyze the strut bar using a von Mises stress distribution plot. Different color indicates different amount of stress acting on each locations. We found that the area experiencing the highest stress, which is around 326.6 megapascal, is located around the fixture point of the strut bar. So we can look at the displacement distribution plot. It can be seen that there is no displacement around the fixture points as it is bolted down onto the chassis. However, the maximum displacement is located at the curve of the bar, which is around 1.736 mm of displacement. Finally, looking at the factor of safety distribution plot, we can see that the part that will yield first is located at the edge of strut bar beside the fixture point. To reduce the risk of failure, we can increase the thickness of strut bar or use material of higher yield stress. That is all from me. Now my groupmate will continue for the second load case.
Assalamualaikum and hi everyone. My name is Nur Shahmirazi bin Hamidan. I'm one of the group. I'm from Group H. So my part, I will explain about load case 2. Okay, for this case, we have said that vehicle hitting a bump at 40 kilometer per hour. When a vehicle hits a bump, the force experienced by the tires are transferred to the strut towers, which is then transferred to the strut bar. For this condition, we need to consider some additional assumption, such as the first one, we only considered front half of the car, and the second one, the weight distribution is 50 to 50 ratio, and the last one, average curb weight similar to before, which is 1416 kilogram. All right. Next, we go to von Mises stress distribution plot. From the stress distribution plot, it is seen that most of part of the strut bar experience the least stress. However, the maximum stress experienced by it is around the fixture holes where the ball is threaded in. The maximum value of von Mises stress is at 27.97 megapascal, which is very much lower as compared to the cornering condition. This is because the vehicle is only hitting the bump at a very slow speed. Next, I'm gonna explain about maximum displacement distribution plot. Uh, uh, from the maximum displacement distribution plot, it can be seen that the strut bar displays most at the middle part where the value of displacement is 22.99 millimeter. We can also observe that the bar experience minimal or almost zero displacement at the fixture points. This is logical as the fixture points have both threaded into strut bar and not allow it to displace at that location. We can also say that the maximum displacement value is much higher in condition 2 than condition 1 as the bar experience more vertical force in condition 2. Last but not least, I will explain about factor of safety distribution plot. The yield strength of material is 800 27 megapascal, and the maximum stress experienced by the strut bar at 40 millimeter size of element is around 27.97 megapascal. The safety factor. The safety factor obtained for our calculation simulation calculation matches the safety factor obtained from the simulation, which is 30. From the factor of safety plot, we can observe that the only part of the strut bar that will fail first is a very small location which sits around the curve of the bar. This means that the strut bar is very much reliable as the amount of stress it is able to withstand is far below its yield stress value. In addition, if by some rare scenario the strut bar actually fails, it will only fail at the small part shown in lower figure. This is very useful as the user can then identify that the strut bar is starting to fail and hence will have enough time to replace it before it fractures completely. Okay, to conclude everything from this project, so to conclude, to compare between both loading cases, the first case where the vehicle is cornering at 1 g-force seems to be the most critical case. The result showed that the loading case 1 will most likely fail and fractures. However, the result is not most accurate as we need to consider other variables that may exist in real life, such as part corrosion and more. The finite element analysis is useful though to help pick the right material and design for a certain part. So that's all from me. Thanks guys for watching. See ya next time.